I welcome everyone to this new video which explains the chapter Structure of an Atom. You can use this video to revise before the exam and that will yield the maximum outcome from this video. I know you all value time very much, so without wasting any more time, let's get into the video. The existence of atom has been proposed since the time of early Indian and Greek philosophers. The word atom is derived from the Greek word atomio, meaning uncuttable in Greek. In 1808, John Dalton proposed the atomic theory of matter on a firm scientific basis. But Dalton's atomic theory had few drawbacks. Before diving into the discovery of subatomic particles, one fact we need to keep in our mind is that like charges repel each other and unlike charges attract each other. Michael Faraday, through his cathode ray tube experiment, observed that cathode rays start from the cathode and move towards the anode. These rays themselves are not visible, but their behavior can be observed with the help of a certain kind of material which glow when hit by them. In the absence of electrical or magnetic field, these rays travel in straight line. In the presence of electrical or magnetic field, cathode ray behaves similar to negatively charged particles. The characteristics of cathode ray do not depend upon the material of electrons and the nature of gas present in cathode ray tube. The charge to mass ratio of electrons can be found using the formula E by me is equal to 1.758820 into 10 to the power coulomb per kilogram, where me is the mass of the electron in kg and E is the magnitude of the charge on the electron in coulomb. This was proposed by J.J. Thomson in 1897. He also argued that the amount of deviation of the particles from their path in the presence of electrical or magnetic fields depends upon the magnitude of the negative charge on the particle. Greater the magnitude, greater magnitude of the charge on the particle, greater is the interaction of the electrical or magnetic field and thus greater is the deflection. Lighter the particle, greater the deflection. When the strength of the magnetic field or the voltage across electrode increase, the electrons deflect from their original path. Through oil drop experiment, Millikan was found that the charge of the electrons to be 1.6 into 10 to the power negative 19 coulomb. The mass of the electrons was determined by combining this result with Thomson's value of charge by mass ratio, and it was found to be 9.1094 into 10 to the power negative 31 kilogram. The cathode ray tube was later modified to found canal rays carrying positively charged particles. Unlike cathode rays, mass of positively charged particles depends upon the nature of the gas present in the cathode ray tube. The charge to mass ratio of particles depends on the gas from which these originate. Some of these positively charged particles carry a multiple of fundamental unit of electrical charge. The behavior of these particles in the magnetic or electrical field is opposite to that observed for electrons or cathode rays. The electrically neutral particles of an atom is called as neutron, and its presence was discovered by Chadwick in 1932 by bombarding a thin sheet of beryllium by alpha particles. In the first chapter, we have seen Dalton proposing that atom is indivisible, but all these experiments have proved Dalton's assumption was incorrect. After the discovery of subatomic particles, the scientists were now facing new problems such as its stability and how these subatomic particles are distributed. J.J. Thomson in 1898 proposed that an atom possesses a spherical shape in which the positive charge is uniformly distributed and the electrons are embedded in it like plums in plum pudding. Plum pudding is common in Britain, so they have used it. We can say it is similar to watermelon. The red portion is positively charged and the seeds are electrons. This model was not consistent in later experiments. Later, when Rutherford and his students bombarded very thin gold foil with alpha particles, they observed that most of the alpha particles passed through the gold foil undeflected. A small fraction of the alpha particle was deflected by small angles. A very few alpha particles, that is 1 in 20,000, bounced back, that is it deflected by 180 degree. On the basis of the observation, Rutherford concluded that most of the space in atom is empty as the most of alpha particles passed through the foil undeflected. A few positively charged alpha particles were deflected. The deflection must be due to enormous repulsive force, showing that the positive charge of the atom is not spread throughout the atom as Thomson has presumed. The positive charge has been concentrated in a very small volume that repelled and deflected the positive charge. Rutherford showed that volume occupied by nucleus is negligibly small as compared to the total volume of atom. The radius of atom is about 10 power negative 10, while nucleus is 10 power negative 15. If we take a cricket ball as nucleus of the atom, then the radius of atom will be more than the whole stadium. According to Rutherford's model of atom, the positive charge and most of the mass of the atom was densely concentrated in an extremely small region called nucleus. The nucleus is surrounded by electrons that move around the nucleus with a very high speed in circular path called orbit. Electrons and the nucleus are held together by electrostatic forces of attraction. The number of protons present in the nucleus is equal to the atomic number. While the positive charge of the nucleus is due to protons, the mass of the nucleus is due to protons and neutrons. The protons and neutrons in a nucleus is together called as nucleon. Isobars are the atoms with the same mass number but different atomic number. For example, the atomic number of carbon is 6 and for nitrogen it is 7, but the nitrogen and one isotope of carbon have the mass number as 14. On the other hand, isotopes have identical atomic number but they vary in mass number. The carbon's atomic number is 6 and it has 3 isotopes which have masses as 12, 13 and 14. As the chemical properties of an atom is controlled by the number of protons, the nucleus have very little effect. The isotope of a given element have identical properties. Rutherford had proposed that nucleus is like sun and the protons revolve around it like the planet. But according to Maxwell's electromagnetic theory, charged particles when accelerated should emit radiation. As planets are not charged particles, there is no problem for them. But the electrons are negatively charged and while applying Maxwell's theory, they may shrink and move towards the nucleus. As this is not true, Rutherford's model of atom also had drawbacks. The dual character of the electromagnetic radiation, which means that radiation possesses both wave-like and particle-like properties, and experimental results regarding atomic spectra led to Bohr's model of atom. Rutherford's model of atom was overcome by Niels Bohr in 1913 in his model of hydrogen atom. Bohr postulated that electrons move around the nucleus in a circular orbits. Only certain orbits can exist and each orbit corresponds to a specific energy. Bohr calculated the energy of electrons in various orbits and for each orbit predicted the distance between the electron and the nucleus. Bohr model of atom, though offering a satisfactory model for explaining the spectra of hydrogen atom, could not explain the spectra of multi-electron atom. Absorption and emission of radiation by heated objects are called thermal radiation. Thermal radiation consists of electromagnetic waves of various frequencies or wavelength. First active study of thermal radiation laws occurred in 1850s and the theory of electromagnetic waves and the emission of such waves by accelerating charged particles was developed in the early 1870s by James Clerk Maxwell, which was experimentally confirmed later by Heinrich Hertz. When electrically charged particles move under acceleration, alternating electrical and magnetic fields are produced and transmitted. These fields are transmitted in the forms of waves called electromagnetic waves or electromagnetic radiation. Maxwell was again the first to reveal that light's waves are associated with oscillating electrical and magnetic character. The electromagnetic wave motion is complex in nature. Here, let us see its simplest properties. The oscillating electrical and magnetic field produced by oscillating charged particles are perpendicular to each other and both are perpendicular to the direction of propagation. Electromagnetic waves can move in vacuum unlike other waves. There are many types of electromagnetic radiation which differ from each other in wavelength or frequency. Different region of electromagnetic spectrum has different name. The small portion around 10 power 15 Hz is called visible light. Special instruments are required to detect non-visible radiation, such as ultraviolet, which has 10 power 16 Hz, and infrared, which has 10 power 14 to 10 power 12 Hz. There is no doubt that Bohr's model of the hydrogen atom was an improvement over Rutherford's nuclear model, but it still had drawbacks such as it failed to account for the finer details of hydrogen atom spectrum observed by using sophisticated spectroscopic technique. This model is also unable to explain the spectrum of atoms other than hydrogen. It was also not able to explain Zeeman effect and Stark effect. Broglie in 1924 proposed that matter also has dual behavior and electrons also have momentum as well as wavelength. From this analogy, we got the equation lambda is equal to h by mv, which is also equal to h by momentum, where m is mass of the particle, d is velocity. This was experimentally confirmed when electron undergoes diffraction. When Werner Heisenberg, a German physicist, in 1927 stated uncertainty principle, which is consequence of dual behavior of matter and radiation, it states that it is impossible to determine simultaneously the exact position and exact momentum of an electron. One of the important implications of the Heisenberg uncertainty principle is that it rules out existence of definite path or trajectories of electron and other similar particles. The effect of Heisenberg uncertainty principle is significant only for motion of microscopic objects and is negligible that of macroscopic objects. The branch of science that takes into account this dual behavior of matter is called quantum mechanism. Quantum mechanics was developed independently in 1926 by Werner Heisenberg and Erwin Schrödinger. Schrödinger gave a recipe to find the energy states of electron in the form of wave function. The energy of electron in an atom is quantized. That means it can only have a certain specific value. By the uncertainty principle, the velocity and position of an electron cannot be determined accurately and can find only the probability of electrons within an atom. The probability of finding an electron at a point within an atom is proportional to the square of wave function. A large number of orbitals are possible in an atom. Qualitatively, these orbitals can be distinguished by their shape, size and orientation. They are principal quantum number. The principal quantum number determines the size and to the large extent the energy of the orbitals. Size of an orbital increases with increase of principal quantum number. Since energy is required in shifting away the negatively charged nucleus, the energy of the orbital will increase with the increase of principal quantum number. Azimuthal quantum number. It is also known as orbital angular momentum or subsidiary quantum number. It defines the three-dimensional shape of the orbital for a given value of n. L can have n values ranging from 0 to n minus 1. Magnetic orbital quantum number. Magnetic orbital quantum number gives information about the spatial orientation of orbital with subshell. The value of this number can have 2l plus 1 values. For example, if L is equal to 1, there will be 3 values and those are negative 1, 0 and 1. Electron spin quantum number. In 1925, George Hugh and Samuel Goldsmith proposed the presence of fourth quantum number known as electron spin quantum number. The spin quantum number can have the values positive 1 by 2 and negative 1 by 2. These are called two spin states of electron and are normally represented by two arrows with opposite signs. The orbitals are categorized on the basis of size, shape or orientation of electrons. As the size of orbital decreases, the density of electrons near the nucleus increases. The square of wave function represents the probability of finding an electron, and this helps in deriving boundary surface diagram to the understanding the shape of atomic orbital. The boundary surface diagram for the s orbital looks like a sphere having the nucleus at its center. S orbitals are spherically symmetric, having the probability of finding electron at a given distance equal in all the directions. The size of s orbital increases with the increase of principal quantum number. The region where the probability of electron reduces to 0 is called nodes in general. ns orbital has n minus 1 nodes. Example, 1s has 0 nodes, 2s has 2 minus 1 nodes, that is 1 nodes. Each p orbital consists of two sections called lobes that are on either side of the plane that passes through the nucleus. The probability of density where they touch each other is 0. In p orbital, the number of nodes is equal to n minus 2. That is, the number of radial nodes is 1 for 3p orbital, 2 for 4p orbital, and so on. The magnetic orbital quantum number of d orbital is given as 2 into 2 plus 1. That is negative 2, negative 1, 0, positive 1, positive 2. These orbitals are designated as dxy, dy square, dxz, dx square minus y square, dz square. Out of the 5d orbitals, the shape of first 4d orbitals are clover leaf shape, and the shape of dz square orbital is similar to donut. According to quantum mechanical model of atom, the electron distribution of an atom containing a number of electrons is divided into cells. The cells in turn are thought to consist of one or more subcells, and the subcells are assumed to be composed of one or more orbitals which the electron occupy. While for hydrogen and hydrogen-like systems such as helium plus ion, lithium 2 plus ion, etc., all the orbitals within a given cell have same energy. The energy of the orbital in a multi-electron atom depends upon the value of n and l. The lower the value of n plus l for an orbital, the lower is its energy. If two orbitals have same n plus l value, the orbitals with lower value of n has the lower energy. In an atom, many such orbitals are possible, and electrons are filled in those orbitals in order of increasing energy in accordance with Pauli exclusion principle and Hund rule of maximum multiplicity. This forms the basis of electronic structure of atom. I hope this section was productive for you, and if you like the section, please subscribe to the channel to get more such videos, and share this with your friends so that they can also save a lot of time in their preparation. Thank you and have a nice day.